Welcome to the Ideal video series on frequently asked questions. This is a series of short videos to explain how to approach common scenarios, model specialized BMPs, or troubleshoot typical issues.
Today's video is about modeling a vegetated filter strip BMP. The vegetated filter strip, or VFS, is a BMP commonly used as a pre-treatment for other BMPs and by itself. When the vegetation is dense and the slope is mild, these BMPs can achieve excellent trapping of pollutants. Most VFSs are grassed, but we will also look at the new option to model existing forested buffer areas as vegetated filter strips. To model, begin by dragging the VFS BMP object into the workspace and double-clicking or right-clicking and choosing Edit. There are three tabs for the VFS inputs. The Physical Characteristics tab features a blue information button in the upper right-hand corner of the dialog box. Clicking on this button displays a diagram of the inputs to show exactly what measurements to enter in each field. The first field is the width of the filter strip. This is measured perpendicular to the flow direction. Next is the length, measured parallel to the flow. This is usually shorter than the width. The slope is expressed as a decimal, not as a percentage, and the input is the vertical change in feet for a horizontal change of 1 foot. So a 4% slope is entered as 0.04. Be careful as you enter this number, because this is one of the most common input mistakes we see in Ideal. The next input is the peak flow for routing, which should be set at 75 or 80%, with the higher being slightly more conservative. This number is used by Ideal to set the average height of flow based on the percentage of the peak flow, and this number is recommended based on empirical studies. The soil texture should match the underlying soil. The degree of saturation is a measure of how saturated the VFS is at the beginning of the storm. The higher the saturation, the lower the trapping efficiency. If the VFS is a grassed area that receives direct sunlight, it will tend to dry well between storms and should be set to 0.1. If it is shaded from trees or a building, it should be 0.3. The next tab is Vegetation Characteristics. There are a number of fields shown here, but the user only makes 2 selections on this page. The first is from the drop-down menu for the land use, indicating whether the VFS will be mowed like a lawn or left to grow tall and only occasionally mowed like a pasture. Next, you choose the type of vegetation by selecting it from a table. The table contains 8 types of grass and a grass mixture. It also shows hardwood forest and mixed hardwood and pine forest. These options were added in version 3.0 and allow a user to simulate pollutant trapping in naturally forested conditions like a stream buffer. The hardwood forest option is typical of mature forests with little understory. The mixed hardwood and pine forest option will simulate a forest with a greater variety of tree maturity and more understory coverage. This option will also provide better trapping efficiency than the hardwood forest, though neither will perform as well as a grassed filter strip. If you choose to model a forested area as a VFS BMP, there are a couple of key points to keep in mind. The first is that a filter strip relies on sheet flow for trapping, and the uneven ground, wide tree trunks, and roots tend to channelize flow. A forested VFS will be relying primarily on leaf litter to filter runoff and capture pollutants, but that leaf litter can be washed away if too much runoff is artificially directed toward it. Designers need to be sensitive to these limitations when modeling a forested VFS and should not direct too much flow to them in order to avoid washing away the ground cover and exposing bare soil. After choosing your vegetation type, the last tab is Bacteria. This is a tab in all BMPs that allows for direct bacteria loading from pets or wildlife. The input is an annual average weight of bacteria-producing animal frequenting the BMP itself per acre of BMP, and then divided by 100. For example, if geese are known to frequent this area, you might assume 1 unit of geese, which is equal to about 6 or 7 geese, or a total of 100 pounds, divided by the area of the BMP. A final point about VFSs in Ideal. Ideal requires the upstream conveyance to be a diffuse channel, which is the program's term for a level spreader. This object is simply letting the program know how wide to spread the flow leading into the VFS and should be set equal to the width of flow in the vegetated filter strip. Once this has been set, you're ready to go.
Thank you for using Ideal. As always, if you have questions about Ideal, please contact the StormOps support team at info@stormopssoftware.com. Also, visit our website and follow us on LinkedIn to get the latest news on support and new releases.